Hi guys, this is lesson 9.6. It's called Analyzing Functions with Successive Differences. So those are big words for something that actually turns out to be pretty simple. But this does tie a lot of our previous lessons together, and so you're going to have to think about things that you've learned in the past. Okay, we're going to be talking about 3 different functions that we've studied. I'll draw them for you. We're going to be talking about linear functions, quadratic functions, and exponential functions. So linear functions make lines, like that. And their equations, if you will remember, look something like y equals mx plus b, where the b number tells us where we are crossing the y-axis, and the m number tells us our slope. If we're looking at a quadratic function, it looks something like this. It is a parabola, and the equation, if it's in standard form, looks something like y equals ax squared plus bx plus c. And then exponential functions we haven't seen for just a little bit, but remember they start out low and then they grow and they climb steeply like that, and their equations look something like this. Y equals something, which is our starting amount, times b, which is our growth factor, to the x, where x is actually the exponent. So in the real world, we have all kinds of situations that we might be studying where we might be recording data. We'll have x values, and then we'll experiment with that x value and find out what y value goes with it. And we might have a data set that we're really not sure what kind of graph it's going to make. So we have to kind of decide which one. If we can decide which one it's going to make and we can make an equation, then we can use that to compute values that we actually didn't record in our experiment, or we can use that to predict things that we don't already know. So it's pretty cool. So I'm going to show you a couple examples here and a technique that we can use where we can actually do some subtracting and decide which would be the best model. Okay, the first situation would be just to graph it. You would take, let's say, graph it and look at it. I'm going to skip over this one quickly so I can get to the subtracting one, because that's the technique I mostly want to teach you in this lesson. If we put in all our x values and all our y values and we look at the graph, we might see that the dots kind of maybe look like that. And you could imagine tracing a parabola there, and you might say, aha, this is probably quadratic. Or maybe you put in your x's and your y's and you hit graph, and maybe, and it doesn't have to be perfect, but you might imagine in this one that you trace that and you say, wow, that's definitely going to look exponential. So the first thing we could do is just to graph it and look at it. But let's say we're just looking at the numbers. Today, let's talk about how to just do a little subtracting magic here, and let's see, put these values in our table for us here. 2, 7, 12. All right, we're going to be looking at the y's. So I'll write that down for you. the y's are here. Here's x and here's y. Y is usually on the bottom or on the right. And what we're going to do is start at the end of the table, and we're going to do some subtraction. We're going to go 12 minus 7 is 5. 7 minus 2 is 5. 2 minus a negative 3, don't let the negatives mess you up. 2 minus a negative 3 is actually adding, and that's 5. And then negative 3 minus a negative 8. Negative 3 minus a negative 8, you'll notice, is also 5. If we get the same number on the first time, on the first subtraction, what we're going to know is that this is linear. Always happens. It's really cool. Okay, let me show you another example, because if we don't get the same number in the first time, we're not going to stop. Put x and y on the table this time. All right, so let's start our subtractions now, and we'll do 0.5 minus 1 is negative 0.5. We'll do 1 minus 2. 1 minus 2 is negative 1. We'll do 2 minus 4 is negative 2, and 4 minus 8 is negative 4. So not the same, right? If it's not the same, we know it's not linear. Whoopsie. Doesn't want me to write on that symbol there. Okay. And then what we're going to do is we're just going to try it again. We're going to go negative 0.5 minus 1 is negative 1.5. Negative 1 minus 2 is negative 3. And negative 2 minus 4 is negative 6. And we still don't have the same, not the same number. If we had the same number right here, we would call it quadratic, but we don't have the same number right here. We haven't studied cubic, but and we won't do that this year. But if we did subtract another time and we got it on the third time, this would be cubic, something with x to the third, and that will continue on the fourth or fifth or sixth subtraction. We can find that our the degree of our polynomial matches that. However, we're going to do something different with this problem. Let's actually create ratios now instead. In fact, hopefully you have room in your notes. I'm going to erase that so that we can actually just start over. And we're going to do, ratio means divide, so we're going to go 0.5 on top of 1 like that. We're going to do 1 over 2. We're going to do 2 over 4 and 4 over 8. And notice that all of these reduce to 1/2. And so since we have a constant ratio, then this is going to be exponential. These are different than the polynomials where we have x to an exponent. These are the ones where x is the exponent. All right, so let's do another example. Let's do this one. -3, -2, -1, 0, 1. -3, -7, -9, -9, and -7. All right, so we're going to start subtracting. You could start by checking for ratios if you wanted to, if you didn't want to start with the subtraction. We're going to do the subtraction here. -7 minus -9. Be very careful with these negatives. Gives me +2, right? -9 minus -9 is actually 0. -9 minus -7 is going to give me a -2, and -7 minus a -3 is going to give me a -4. So it's not linear because we didn't get a constant number on the first subtraction. So we're going to switch and do a second subtraction. 2 minus 0 is 2. 0 minus a -2, watch out for these negatives, is a +2. And -2 minus -4 is going to give me a +2 also. So constant difference on the second subtraction is going to give me a quadratic situation. It's going to be when I put all of these x's with their y's and plot the dots on the graph, then it's going to look like a parabola, and we're going to end up with an equation that has an x squared. It's going to be a second degree polynomial. All right, let's do one more example. And there's a lot we can experiment with in the calculators, but the big concept I want you to grab onto today is how to do this subtraction. Let's say we have -4, -3, -2, -1, 0, and 32, 18, 8, 2, 0. I can check ratios right up front if I want. I would do 0 divided by 2 is 0. 2 divided by 8 is 1/4. 8 divided by 18 is not going to be 1/4. So it's not exponential because there's no constant ratio. So I'm going to start subtracting. I'm going to do 0 minus 2, -2. 2 minus 8 is -6. 8 minus 18 is -10. And 18 minus 32 is -14. Let's go ahead and subtract again because it's definitely not linear. -2 minus -6 is a +4. -6 minus -10 is a +4. And -10 minus -14 is also a +4. Use a calculator if things are messing you up. This is quadratic. It is second degree. It is going to have x squared in our equation. It's not going to have x to the third or the fourth. It's only going to have x to the second as our highest degree. And that's all we're going to cover of those for right now. Let me know if you have some questions.